everyone, I'm Matus, Steis, token design lead at Outlier Ventures, and this is the third episode of a new Outlier Ventures series where we are going to cover a range of topics related to token design, such as token economics, mechanism design, and token engineering. And our primary goal here is to help our audiences understand the core principles behind token design. Outlier Ventures or I may hold tokens mentioned on this show, but nothing said here constitutes financial advice, so please do your own research before making any investment decisions. And today I'd like to welcome Dr. Michael Zargham, who's the founder and CEO of BlockScience, which is a complex systems engineering research firm with a focus on social and economic networks. Very good to have you here, Dr. Zargham.
Oh, thank you for inviting me.
So to kick off, can you please tell us something about your background and about what BlockScience does?
Sure. So my personal background is that I worked on multi-agent systems, robotics, and also social and economic systems starting in the early 2000s. I worked with a researcher by the name of Reza Olfati Saber at Dartmouth, and then with Ali Jidbabai at the University of Pennsylvania. Ali is actually the director of socio-technical systems at MIT now, and the department chair in civil engineering, I believe, which is a bit odd, actually, because civil engineering is not traditionally what you associate with control theory and multi-agent systems necessarily, but I actually consider this to be an important indication that we're viewing our social and economic platforms and data-driven systems as part of our social and economic infrastructures, which I think is a good lead into the discussion of sort of token engineering and, economic system design.
Mm-hmm. Mm-hmm. Definitely. And so let's stay with the term token engineering. How would you define it? Would you say it's more of a methodology or a movement?
Interesting. I think these are two different things, but it can be both. So methodologically, we can talk about how we apply the engineering design process, which is something more generally used in complex engineered systems with multiple parts and maybe multiple stakeholders, or any system that is too much complexity to sort of hold all in your head all at once, where you have to modularize and design things and talk about how they interact with each other. That's sort of why we have an engineering design process. And token engineering aims to use the tool tokenization alongside an engineering design process to manifest a social or economic system that has some desired properties at the sort of higher system level, users, stakeholders, etc. As a movement, though, we can interpret token engineering as the sort of social system or community around applying engineering principles. And this is because engineering as a community or as a field has some slightly different I would say, values to what we would associate with sort of just, developing software. And in particular, those values revolve around infrastructure and like serving the public good. And if you have a formal engineering education, you have ethics and you have considerations of how your work directly affects those who use it, full life cycle analysis, things like designing for something to last a long time, or what is effectively sustainability, or in some cases end of life, or understanding how a system can go from existing to not existing safely. There's a lot of considerations that are implicit in the term engineering from a social institution perspective that differ from sort of just the software development world. But I think we see those values being injected into the token engineering community and into Web3 at large by people who are choosing to associate with the token engineering as a movement, not just as a methodology.
Interesting. So as a movement is mainly about kind of making sure that there is a level of thoroughness when it comes to designing these systems.
It's not just thoroughness, because a lot of real engineering is also driven by the iron triangle, right? Like time, money, and scope. And you can't just magically make the extra time to do all the things, but you have to make subjective trade-off choices, and you need to balance multiple goals. And I think that is something that often gets lost in the sort of very overly computer science centric view, where my feeling has been that we have a sort of deterministic, like, we tell it to do this and it does this. But the truth is that as you move up stack and you build things that are higher and higher compositions of components, including software, and many computer scientists work on things like cyber physical systems where they have to deal with these kind of trade-offs and, multi-criteria, multi-stakeholder, subjective choice in a design space problems. But ultimately, I would say that's where we have the need for engineers in the traditional engineering sense, as opposed to engineers in the I make stuff sense.
No, that makes sense. That makes sense. And you are probably one of the most suitable people to ask this question. What is a token?
Okay, so my real answer is going to be that a token is a representation of state in a state machine. Now, that's super general. So we could have tokens like NFTs, which are representations of some discrete object. And we could have representations of tokens like ERC20s that are sort of continuously valued things that you can transfer. They're conserved, and although technically still discrete objects because they have they break down and they're divisible up to some number of decimals. These are just examples of things who are stored in this sort of distributed database or distributed virtual machine. And I would define a token as being a sort of a unit or an atom of that shared state. And now mutating tokens could be things like transferring transferring Ethereum to you. It might also be about minting a new NFT, which maybe it's like a proof of attendance protocol token, which can't be transferred once you have it. It's a statement or a claim, but it's still a unit of state in this virtual machine that I can prove to someone else. Kind of moving up stack, though, people talk a lot about token design actually in terms of the pattern or the instance or maybe the factory. So like if you were designing a class of tokens, then you might have to have a smart contract that could mint them or controls their transfer. Or if you're designing a factory of basically 4 smart contracts, 4 tokens, you could look at something like a balancer or a Uniswap where the protocol itself sort of describes the software that you use to create an instance of a liquidity pool, which itself contains 2 other tokens or more in balancer's case, but it also creates the liquidity provider token, which is the tool for coordinating it in providing liquidity. And so now it gets really blown up really fast, right? Is the token the instance of the liquidity provider token, the right to redeem? Or is the token the pattern, say Uniswap? Is the token is the token design the design of the pattern that allows you to instance of a liquidity pool? Or honestly, as you move up further, we see the usage of liquidity pools as subsystems in a wide range of other applications. So we were discussing earlier, lately I've had the opportunity to collaborate with some awesome folks at Reflexor Labs on the Rye project. And that system has a Uniswap instance sort of in the system because it requires effectively a secondary market in the form of a Uniswap instance in order to interplay with the debt-based system. It's similar to MakerDAO, but without a pegged price, and in fact is based on many of the original designs used for single collateral DAI before they settled finally on the fixed price model. And in fact, that system works in tandem, or the debt-based system works in tandem with a secondary market. And so you could argue that the subsystem or component system instance of Uniswap, or more generally the secondary market at large, is a part of the token system that includes this debt-based mechanism where you lock up Ethereum for the right to borrow Rye. And then what do you do with it? Well, you maybe use it to donate to Gitcoin grants, or you maybe put it into the liquidity pool so that other people can buy and sell it. I don't know. The behavior is pretty wide. And this is why I like to come back to this idea of infrastructure, because ultimately these tools, they don't demand that people do anything. Though I guess to be clear, Rye sort of demands that people short it if the price gets too high. Its mechanism is designed to be semi-stable by creating incentives for people to short it when the price is higher than its redemption price, or to buy it if its price is below the redemption price. But even still, it doesn't actually make them do that. And so it's important to recognize that these systems offer a sort of activity space, or these like range of activities that people can undertake. And, up to some degree, they constrain or guide that activity, but there's also many degrees of freedom through which people interact with each other or interact with other contracts. And that kind of has this essence of physical infrastructure where you can try to build it, you can try to make it robust, you can try to make it safe, but you have to account for, I guess in roads and bridges, right? Traffic patterns often are inherently behavioral, despite the structural nature of the roads. And at the end of the day, you need something that can be safe in different weather conditions with somewhat realistic assumptions about behavior, rather than just the idealized ones. And I guess to kind of end that tangent, the idea here is that good engineering design isn't as simple as the roads should be this grade and this sort of width and whatnot. It ultimately comes down to evaluating under what conditions it's safe. Is it safe when it's raining still? Yes. Is it safe when someone's drunk driving? Well, no, but we can still make it safer by making the roads a little wider, or to put guardrails between the lanes and do things that don't stop people from making behaviors that maybe we would consider undesirable, but nonetheless secure the system from some sort of, cascading breakdown that might emerge from, the realistic undesirable behavior occurring. And for something like RAI, that comes into saying, well, we know the system's incentivizing people to short when the price gets too high, as above the redemption market price is above the redemption rate, but maybe they're not so good at doing this to the extent that we would like. Maybe they're too concerned about future airdrops, or they're too concerned about the frictions associated with shorting. You have to deploy a proxy contract and open a safe, and that friction affects behavior. And so if they're not doing it, do we want the system to, simply, blow up? Well, of course not. And so there are, designs and iterations on the designs that allow that system to simultaneously induce the desired behavior, but have some cushion so it doesn't, break if people don't do what it wants them to do.
That makes sense. That makes sense. So when we are trying to understand, various token design models of different projects, it makes more sense to talk about the system as a whole, not just about the token as such, because the token is only a unit of state of that system.
And even the pattern of the token might vary with context. So you can think of the token design as co-fit with the application. So the perfect token for your system might be terrible for mine, and vice versa. So if we try to analyze it at the level of, is the token design good or bad, you're going to end up with this sort of copy pasta mentality that actually creates actually unsafe systems or unsustainable systems, even if you're observing that it was working for someone else. And that kind of goes back to the bridges and roads analogy, right? Like, you can get the gist of, say, a suspension bridge, but if you try to take the exact suspension bridge from that place and put it over here, it's not going to fit. So you have to figure out how to take the core concepts and apply an engineering design process to map it over and make it useful and achieve the properties that you want in your system with the context of your system in mind.
Makes sense. And then to kind of for our wider audience, what would be your advice to people who are not in the space full time, but are trying to evaluate various token models of different projects? What are the key aspects to analyze if one needs to form an opinion on a token project?
Yeah. Okay. So I would say at the highest level, tokens don't make value out of thin air. I know that people sometimes experience that in the short term due to the hype cycles at their deployment, but the truth is that the long-term value creation has to come from somewhere. I think of it a bit like energy conservation. These token models can do a really good job distributing value more fairly, but it has to come from somewhere. So I tend to break my view of, like, if I'm just doing a quick overview, I'm thinking about the network's capacity to export value and the ability of that token to sort of distribute fairly the payments for, or whatever the value inflow is. So if my network is exporting something, then presumably it can capture some value, and it might be directly through payments and those allocations, or it might be that a token is being used to sort of coordinate the efforts, and thus the value could be captured by the token at large, in the sense that if you have to buy a token to participate in a coordination process, and then that coordination process in turn produces or exports a lot of value, then the idea is that that can collectively produce a sustainable ecosystem whereby the value of the token starts to reflect this sort of value of the system's exports. But you get a kind of layering going on where there's a sort of currency market macroeconomic view where you're like, this token sort of represents this whole economy, and all we see at the price level is some valuation implied by price. But inside, in the sort of meso, or the meso layer and the micro decisions of the agents, you see a lot of individual decisions associated with direct participation and the proceeds of that effort. And that can vary widely because the nature of the coordination amongst the participants vary widely. So some things that we've seen that I think are maybe patterns are things like the revenue sharing types of models that are presented in something like the graph, where delegators essentially stake on operators, which are called indexers, and that gives them a right to a share of the revenues produced by that. And the reason I like that is because it's ontologically very similar to things that you could see in sort of real life coordinations anyway. But I think the downside of this is that you kind of got to know what you're doing. In a way, those delegators have a curation-like role, although they're distinct from curators, of identifying service providers, in this case indexers, who do a good job and can be expected to do a good job in the future. And in turn, then people are more likely to use them to solve their queries, and in turn, they make more money. And so you end up seeing this sort of dynamic multi-stakeholder coordination emerge, but it's also exporting value in the form of these this query service. And what you see with the graph, for example, is a lot of people use their subgraph query service. So you can see the exported value and the coordination problem happening concurrently, and they're, again, co-fit, in the sense that it wouldn't make sense to, sort of have the token be valuable if it wasn't facilitating real coordination, and if that real coordination wasn't producing something that other people externally consumed.
So it's about coordination, which creates additional value, essentially.
Right.
Okay.
Yeah. And it's actually, I know that I made it sound probably complicated, but as a heuristic, you're just basically saying, does the token help the network coordinate to achieve something? Does the thing that it achieves export value beyond the scope of that group? And if that's the case, then there's a reason to believe that that economy is sort of able to grow, like an island economy suddenly connecting to the global economy. You're like, we are exporting. If we're not exporting, we've got a problem.
I understand. Makes sense. All right. This was very interesting. Thank you very much, Dr. Zargham, for coming in, and we hope to see you again soon here.
Thanks for having me, and good luck. I'm excited that you guys are doing this cast.
Thank you. Hope to see you soon. Finally, a couple of words on Outlier Ventures. We have been investing and accelerating the Web3 ecosystem since 2013. In 2019, we launched Basecamp, which is an accelerator program for pre-seed startups operating in DeFi, NFTs, and open data. What we do is that we provide capital, we help with your token design, we give you access to our network of the best investors and founders, and we also give you back office support and mentorship. So if you're a Web3 founder, be sure to check it out. Applications are now open.